Good. Welcome to electrostatics. I'm just going to try and do some demonstrations here quickly to get you thinking about electrostatics and specifically the movement of electrons, hence the name electrostatics. So what we have here is, we call it a pith ball. It's basically a piece of cork on a string. And here I have a rabbit, but it's just part of a rabbit, unfortunately. It's just the fur. And here I have an ebonite rod, and it's a piece of rubber, hard rubber. And what we're going to do here is we're going to rub the ebonite on the fur. And what's happening as I'm doing this, I'm charging by friction. Electrons are being transferred from the fur to the ebonite, because the ebonite loves to gain electrons. And now I'm going to hold it close to the pith ball and see what happens. And as you can see, they get immediately attracted. Right, so they're immediately attracted. Now all of a sudden, you should be, hopefully you can see that they're actually repelling now. They're repelling quite strongly. So what's with that? What happened there? Oh my gosh, yeah, I'm not doing anything with my hand here. That's repelling very strongly. What happened? Well, here's what happened. When I was rubbing the ebonite on the fur, electrons were being transferred onto the ebonite. So now all of a sudden the ebonite has an excess of electrons. In other words, it's overall negatively charged. When I hold it close to the pith ball is neutral, has the same amount of protons as electrons. All the electrons in the pith ball are going to be pushed over to the other side, because they're going to be repelled by the electrons in this, and therefore this side of the pith ball will gain a positive charge, and it will therefore be attracted to the rod. Now I got to ground everything here, so it will be attracted to the rod, because although this remains neutral, all the electrons are being repelled, so they go over to this side. The rubber rod is over here, and therefore, this side of the pith ball is positively charged. It will be attracted to the negative charge. Let's see if we can do that again. There it is. There it is. Now they're touching. Now when they touch, this is called charging by conduction, the electrons are allowed to transfer onto the pith ball, and that's eventually why you see it just released, and now it's repelling very strongly, because now the pith ball has an excess of electrons. Because they touched, the electrons were allowed to transfer over to the pith ball. So now they're both negatively charged, and that's why they're repelling quite strongly. Okay, and then very quickly, the same thing happens if I rub silk with glass, except for it's the opposite. So when I rub silk and glass together, the silk loves to be negatively charged, and the glass rod loves to be positively charged. Now electrons are going from the rod, the glass rod, onto the silk, and now this becomes overall positively charged. And because that pith ball was already negatively charged, they attract quite strongly. Let's try that again. They're attracting quite strongly, and in fact strongly enough that it will actually defeat gravity. And so they're attracting strongly because this glass rod is positively charged. I had already negatively charged the pith ball from the ebonite, and so that's why they're attracting. Now, if I keep this long enough, eventually they're going to start repelling, but there's all kinds of electrons leeching on and off, and so they're still attracting quite strongly. Eventually, it will start repelling. Just doesn't want to. I guess they really like each other, these two. Anyway, that's the basis of charging by friction and charging by conduction. So hopefully that gives you a look into how electrons move from object to object, and that will make the next few lessons easier.